All right, calculus scholars, back here for the problem portion of skill 25 with the delta math. Um, so one thing that's kind of nice about delta math is it kind of has some nice interaction with the graphs. And these are actually going to build some really good conceptual understanding of derivatives graphically for you. So what this is saying is it's going to ask us to determine the intervals for which the function is greater than or equal to 0. So what this means, basically, I like to convert the geek speak into plain English. So this means that our y value is greater than or equal to 0. And what we notice here is right at -5 and right at 4. Well, actually, there continues to be greater than or equal to 0. So it pretty much ends right at 9. So from -5 to 9, we are greater than or equal to 0. So I like to, and actually I'm going to use square brackets because technically your y value at -5 is exactly 0. So we're still good. So my interval notation would just be -5, comma, 9. All right. So I think that's pretty self-explanatory. I mean, we're going to kind of start you basic on those. And then we're going to kind of work you a little bit up. The next exercise is to kind of move to the idea of looking at terms and conditions for the derivative and the original function. So this says, given the graph of the function above, determine all the intervals on the open interval -9 to 9, where f prime of x is greater than 0 and f of x is greater than 0. Now, this looks like Greek a little bit. My advice to you is to turn this into a pre-calculus problem. You can actually turn this into a pre-calculus problem. So what we're saying here is that we are saying if the derivative is greater than 0, this means that the function is increasing and our y values are in positive range. You could just say f of x is greater than 0, but I mean, basically this problem, where is the function increasing and positive? And when I kind of change it to that, even a student that's well before calculus could actually do this type of problem. So let's look at the areas where the graph is increasing. And to affirm that we are increasing, you can even use the toggle here and see when the slope becomes positive. So we need both increasing and we need positive y values. So right at, and we're going to use the curved bracket here because we are strictly greater than 0. So at -4, that's where we cross 0 in y value, and we're increasing all the way to -3. Now I could even move my slider. And at -3, we're exactly 0. Now we're decreasing for a while. Now here, we are back in positive, strictly above 0. So 1 to 3 would be next. And then I have 5 to 9. And then that should be enough information, actually not 5 to 9, 8 to 9 actually, because we have to also meet the condition of it being positive. So it really does turn out that if you turn this in to pre-calculus terminology, it's going to be a much easier problem for you. So really work on translating the geek speak first. Hey, that could be a good motto. Translate the geek speak. All right. The next question, I really love this question, and I always loved giving this on like even the old school pencil and paper mastery assessments. A question like this, I always tried to find one. It's nice and conceptual. What I like to do with this, and pretty much this is asking to compare the slopes, and I like to just kind of categorize and see, is it positive, negative, or 0? So here, f prime of -1 is equal to 0. F prime of 2, this is increasing. So f prime of 2 is positive. And then f prime of 6 is decreasing. So that's negative. And then I can kind of just order. So I could actually do, I could say f prime of 6 is smallest. And then I could say that f prime of -1 is the next smallest. And then I could say that f prime of 2 is my biggest. So I'm going to actually look for that answer choice. 6, -1, 2. That looks good. Let's kind of actually look at an incorrect answer choice. So if I wanted to do like an incorrect one, here's what would happen. So like if I had f of -1, that's 0 in slope. F prime of 2, this is increasing, so that's positive. So far, so good. But then the problem is we get to 6 and we're negative. It doesn't make sense that a negative number is bigger than a positive number, or a positive number is less than a negative number. So that's why that does not work. All right. Now the next type of problem that we're going to do is analyzing the derivative graph, level 1. So on this, it says the graph of f prime of x. So this is important. This is not the graph of the original function. This is the graph of the derivative of the function. Determine the values of x, if any, at which the function f has a critical value on the interval -9 to 9. So critical value means that we are looking for where the derivative is equal to 0. So note that critical value means that f prime of x is equal to 0. So we're looking for where the function is hitting this red line. And it is hitting precisely at -4, 2, and 8. And there we have it. And it does kind of give you a connection. You could even kind of help you think ahead. It actually gives you the derivative graph, and then it actually even gives you the graph of the original function as well when you are looking at the solution. Okay, the last type of question is called the chart question here. And it's asking you to kind of make some inferences about particular x values and kind of observing here. Now, the way that you do this question, well, let's see. If I have f of 4, what that's telling me is for value, obviously it's positive. In pre-calc, we may say, okay, what's this point called? And you can just go through the drop-down menu, and it is a, let's see, we got relative max, relative min. It's definitely not increasing. It is at least a relative max. And is there a sign change for that? No, because it's particularly positive. Now, for the f prime, what that's asking is it's asking for increasing, constant, or decreasing. It's asking about the slope. So I'm going to just scroll right back up. And at 4, it turns out that our, sorry about that, our internet just crashed. So it turns out that our slope is 0. Actually, it's f prime of 4. So and then for sign change, well, we're going from like increasing to decreasing. So that's code word for positive to negative. And we are good. So I just kind of wanted to walk through each of these exercises. They're kind of like what you've never seen before, and you may have to, kind of look at the patterns and kind of get your mind around them a little bit. But if you work on translating the geek speak into kind of like plain English, so knowing that f prime of x is positive, meaning that the graph is increasing, f prime of x is negative, graph is decreasing, you will be in really good shape with these. So thank you very much for checking in, and looking forward to practicing with you next class on Delta Math.